Article 408(36) addresses disconnecting means for branch circuits. Subparagraph A general has several points. Firstly, where a branch circuit is controlled by more than one disconnect, each disconnect shall comply with the marking requirement of 408(36)(d). Secondly, each two-wire branch circuit shall be provided with a disconnect having not more than two current carrying poles. Thirdly, each three-wire branch circuit shall be provided with a disconnect having not more than three current carrying poles. Fourthly, branch circuits supplying only auxiliary gutters shall not be required to be provided with disconnecting means at the point of supply. Fifthly, each branch circuit supplying lighting fixtures or other loads on the exterior of buildings shall have disconnecting means readily accessible in the building. Subparagraph B, single circuit, states each single circuit shall be provided with a single disconnect. Subparagraph C, multiple circuits, has a few provisions as well. Firstly, where more than one circuit is controlled at a single point, a single disconnect shall be permitted for such circuits where the rating of the disconnect is sufficient for the combined loads. Secondly, where more than one building or structure is supplied, the disconnecting means shall be grouped and shall be located in an accessible location for each building or structure. Thirdly, where the disconnecting means is installed adjacent to a panel board, the branch circuit switching devices located therein shall have a rating not less than the disconnect, and the rating of the panel board busbars shall be not less than that of the disconnect. Subparagraph D, marking, states each disconnecting means shall be marked to indicate the circuits controlled thereby. According to the current section, a 30-amp non-fusible disconnect for 20-amp air conditioning feed from a 20-amp circuit breaker is permissible. The non-fusible disconnect serves as a safety disconnect. It isolates the circuit during faults or emergencies. However, the non-fusible disconnect is not an overcurrent protective device. If a fault occurs in the air conditioning circuit, the 20-amp circuit breaker should trip and interrupt the fault current. If the non-fusible disconnect has a higher rating than the circuit breaker, the disconnect might not trip. It could allow the fault current to continue flowing and potentially causing damage or fire. Coordination is essential in overcurrent protection. The overcurrent protective device closest to the overcurrent should trip first. In this case, the 20-amp circuit breaker must trip before the 30-amp non-fusible disconnect. While the code allows for a higher rated disconnect, it is generally recommended to use a disconnect with the same or lower rating than the circuit breaker. This ensures proper protection and coordination within the electrical system. In the situation that was brought up, a 30-amp non-fusible disconnect is used as a safety disconnect for a 20-amp air conditioning feed from a 20-amp circuit breaker. To break this down further, firstly, overcurrent protection is a critical aspect of electrical safety. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from excessive current, which can cause overheating, damage to equipment, and even fires. Secondly, a non-fusible disconnect is not an overcurrent protective device, but it is a safety disconnect which is intended to isolate the circuit in the event of a fault or other emergency. Thirdly, if the air conditioning circuit develops a fault, the 20-amp circuit breaker will trip and interrupt the flow of current. However, if the non-fusible disconnect is rated higher than the circuit breaker, it may not trip, which can cause damage or a fire. Fourthly, overcurrent protective devices should be coordinated, so the device closest to the source of the overcurrent trips first. In this case, the 20-amp circuit breaker should trip before the 30-amp non-fusible disconnect. Fifthly, it is generally recommended to use a non-fusible disconnect that is rated the same as or lower than the supply circuit breaker. A disconnect rated higher than the circuit breaker may not provide adequate protection. In summary, it is important to consider the overcurrent protection, fault current, and coordination of the electrical system when selecting a non-fusible disconnect. It is also important to consult the relevant electrical codes and standards to ensure that the electrical system is installed and maintained safely.